Welcome to this video on identifying the height of a parallelogram, triangle, and trapezoid in different orientations.
Welcome to Math Challengers.
Let's begin by focusing on the heights of a triangle. In this first orientation, we can see vertex B and base AC. The height of a triangle is the perpendicular distance from the vertex to the line containing the opposite side, which is the base. Here, we identify height BD. Moving to orientation 2, we identify vertex C and the corresponding base, BA. Following our definition, we can find the height CD by measuring the perpendicular distance from vertex C to the base. In our third orientation, we locate vertex A and the base, which is segment CD. The height, AB, is the perpendicular distance from vertex A to the line containing the base. As you can see, the height depends on which side is considered the base. Since all three sides can serve as a base, every triangle has three possible heights. Let's look at an example. In this triangle, we can see the perpendicular height is 5 centimeters. Here is another example. By identifying the perpendicular line from the vertex, we find the height is 9 centimeters. In this final example, the identified height of the triangle is 6 centimeters. Now, let's practice. Can you identify the base and height of this shape? Based on the dimensions shown, the base is 8 centimeters and the height is 10 centimeters. Finally, here is one more shape for you to analyze. Try to identify the base and height. Let's apply our skills to identify the base and height of the next shape. Now let's explore the heights of a parallelogram. In this first orientation, we can see the perpendicular distance from the top side to the base, which gives us a height of 4 centimeters. Looking at orientation 2, the parallelogram is tilted. Here, the perpendicular height from the top edge to the bottom is 6 centimeters. In the third orientation, even when rotated, we look for the perpendicular segment. The height here is 4 centimeters. Notice that it is the same height in orientation 1. Finally, in orientation 4, the perpendicular height is clearly marked as 6 centimeters. Notice that it is the same height in orientation 1. Remember these key steps when finding the height of a parallelogram. Pick your flat base side. Look for the 90-degree square corner that forms an L shape with the base. Ignore slanted sides. Never use a sloped side as your height. The height can sit inside or outside the figure depending on the base. Let's practice identifying dimensions on this shape. Based on the diagram, the base is 12 centimeters and the height is 7 centimeters. Here is another example for you to observe the base and height labels. Next, let's learn about the heights of a trapezoid. In this first orientation, we can identify the height of the trapezoid as 7 centimeters. When we look at orientation 2, the perpendicular height is measured at 7 centimeters. Moving to the third orientation, we can again see the height marked as 7 centimeters. In this final orientation, the height remains 7 centimeters. Remember, while triangles have 3 potential heights and parallelograms have 2, a trapezoid has only 1 height because it has only 1 pair of parallel sides. Now let's practice with a trapezoid. Here, we can identify the first base at 12 centimeters and the second base at 15 centimeters with a height of 8 centimeters. In this next example, we have a trapezoid with a first base of 15 meters and a second base of 20 meters and a height of 9 centimeters. Now it's time for a quick formative assessment. Complete the table on your worksheet by identifying the base and height measurements for each of the 6 figures. Remember, height is always drawn perpendicular, or at a right angle, to the base. Let's CHCK your answers 1. Thank you for watching this video on identifying heights for triangles, parallelograms, and trapezoids. Keep practicing these geometric concepts